Welcome to Section 11, Lesson 5. The quadratic formula is the universal solver for any quadratic equation, whether the trinomial factors has irrational roots or has complex roots. The formula handles all cases without any case analysis. The formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Memorize this, it appears constantly through the rest of algebra and into calculus. The expression under the square root is called the discriminant, written delta. It equals b squared minus 4ac. The discriminant alone tells you how many roots and what type before you finish solving. 3 cases. Discriminant positive 2 distinct real roots. Discriminant 0 1 repeated real root. Discriminant negative 2 complex conjugate roots. Section 12 handles the complex case in detail. Take x squared plus x minus 2 equals 0. The parabola crosses the x-axis at 2 points, so we expect 2 real roots. Identify a b, c by matching to standard form. A equals 1, b equals 1, c equals negative 2. Compute the discriminant first. B squared minus 4 as c equals 1 minus 4 times 1 times negative 2, which equals 1 plus 8 equals 9. Discriminant is positive 9, so 2 real roots and the square root works out cleanly. Plug into the formula. X equals negative 1 plus or minus 3, all divided by 2. The two solutions are x equals 1 and x equals negative 2, both visible at the parabola's x-axis crossings. Solve 2x squared minus 5x plus 1 equals 0. The trinomial does not factor over the integers, but the quadratic formula works regardless. Identify a b, c, a equals 2, b equals negative 5, c equals 1. Plug in. X equals 5 plus or minus the square root of 25 minus 8 all over 4. The discriminant is 17, which is positive but not a perfect square, so the roots are irrational. Simplify. X equals 5 plus or minus the square root of 17, all divided by 4. The two decimal approximations are about 2.28 and 0.22, both visible as parabola crossings on the graph. Example 2. The discriminant predicts the number and type of roots. 3 sample parabolas illustrate the 3 cases. Discriminant greater than 0. The parabola crosses the x-axis at 2 distinct points, producing 2 real roots. The square root of a positive number is real, and the plus or minus splits it into 2 distinct values. Discriminant equal to 0. The parabola touches the x-axis at exactly 1 point, the vertex. The square root of 0 is 0, and the plus or minus collapses to a single repeated value. Discriminant less than 0. The parabola does not reach the axis at all. The square root of a negative number is imaginary, so the formula produces 2 complex conjugate roots. Useful when modeling oscillations, signal phase, and other complex valued problems handled in Section 12. 3 takeaways for the quadratic formula. Memorize the formula x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Plug in a b, c from standard form, and the answer is always correct, regardless of whether the trinomial factored. Compute the discriminant before plugging through. Discriminant equals b squared minus 4ac. It is a single number that tells you the type and count of roots before any further work. 3 cases. Positive discriminant gives 2 distinct real roots. 0 discriminant gives 1 repeated real root. Negative discriminant gives 2 complex conjugate roots that Section 12 will revisit. Knowing the case in advance prevents confusion when the answer comes out non-real.